Hello everyone, welcome to my channel. In this video, I will give you the introduction of two-port networks and open circuit impedance parameters, also called as Z parameters. Two-port networks. Generally, any network may be represented schematically by a rectangular box. Okay, so a network can be used for representing either source or load or for a variety of purposes. Port is nothing but it is a pair of terminals at which signal may enter or leave a network. A port is defined as any pair of terminals into which energy is supplied or from which energy is withdrawn, or where the network variables can be measured. If you see here, this is a one-port network where you can see only one port. Port or nothing but here 1 dash. A port is a pair of terminals into which energy is supplied or from which energy is withdrawn, or you can say that at which signal may enter or leave the port. And this is a two port network where a network is represented by black box. It consists of a two pair of terminals here. 1 dash is one pair, 2 dash is another pair. So we have two ports. It is named as two port network. And the variables represented at port 1 are V1, I1, and the variables represented at port 2 are V2 and I2. Two ports containing no sources in their branches are called as passive ports. Two ports containing in their branches which have active sources are called as active ports. And we are assuming that I1 and I2 are entering into the network. And out of these four variables, two will be dependent variables, two will be independent variables. And number of possible combinations generated for these four variables are 4C2. 4 factorial by 4 minus 2 factorial into 2 factorial. So 4 into 3 into 2 into 1 by 2 factorial into 2 factorial. So 2 into 1, 2 into 1. So we can have 2 gets cancelled to total 6 combinations. There are 6 possible set of equations describing a two-port network. Let us see the first set of equations now, that is Z parameters. Also called as open circuit impedance parameters. This is a network and this is port 1 dash, port 2 dash, assuming currents are entering into the network. Voltage across port 1 dash is V1, voltage across port 2 dash is V2. Z parameters are described by the equations V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. We can represent the above equations in matrix notation as V equal to Z into I, where V can be represented like column matrix V1, V2, and Z matrix is nothing but Z11, Z12, Z21, Z22, and I can be written as I1, I2. If you multiply these two matrices and equate on left hand side, you will get the same equations. And the numbering has been given like Z suffix 111. This is first row, first column. And 12 is given like first row, second column. Z21 is second row, first column. This is second row, second column. Okay. Z parameters are also called as open circuit impedance parameters. This is how we can represent a two-port network. We have a port 11 dash, port 22 dash. Voltage across 11 dash is V1. Current entering into the network is assumed as I1, and voltage across 22 dash is V2. Current entering is considered as I2, and the equations are given by V1 equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. And matrix notation or matrix representation for the above equations can be written like this. Okay, Z11, Z12, Z21 and Z22 are called Z parameters. Let us define each and every parameter now. Let me rewrite the equations. V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. To have Z11 can be written as V1 by I1 when I2 equal to 0. Right? Whenever this term becomes 0, we can have Z11 equal to V1 divided by I1. When I2 becomes 0, this will happen. Okay. So Z11 equal to V1 by I1 when I2 equal to 0. Next, Z12. Similarly, we can write Z12 equal to V1 by I2. From this equation we are writing. From this equation V1 by I2 when I1 equal to 0. Next, Z21. Z21 equal to, we can write from this equation, V2 by I1 when I2 equal to 0. And Z22 equal to V2 divided by I2 when I1 equal to 0. These are the Z parameters we can write from the equation. Let us define each and every parameter in sentence form. Z11 is called, here you can see I2 equal to 0. So I can take it as open circuit, as the condition is here I2 equal to 0. When I equal to 0, we call it as open circuit. If we equal to 0, we start it as with short circuit. And here I2 equal to 0, I'll just call it as open circuit. And then here we have ratio of V1 by I1, that is variable ratio only at port 1. So I can take it as port 1 is input port. So 11 dash is input port and 22 dash is considered as output port. Okay, port is a pair of terminals at which signal can enter or leave the network. And I'll write, as this is the ratio of variables which are at port 1, I'll write this as input. Next, V by I. V by I is nothing but impedance. I'll write this word as impedance. So Z11 is defined as open circuit input impedance. Next, Z12. Z12, again I look at this condition. This condition is I equal to 0. I'll just write it as open circuit. If you see the condition as V equal to 0, you write it as short circuit, which we will encounter in that case when we discuss Y parameters. I equal to 0, open circuit. Then look for the ratio, whether it is 1 to 2 or 2 to 1. So it is the ratio of input port to output port. When you see the ratio of input port to output port, you write reverse. And next, look for the ratio V by I. V by I is impedance. And as this is 1 to 2, and we can write here reverse transfer, because this is, we are going to write the ratio of one variable of one port to the other variable of other port. So V by I is impedance. Z12 is named as open circuit reverse transfer impedance. Next, Z21. Again look at the condition I2 equal to 0. So we can write open circuit. Then look for the ratio. This is port to 2 variable to port to 1 variable. Fine. So always the ratio, if the ratio is output side by input side, we will write forward. If the ratio is input side by output side, we will write the word reverse. So this is open circuit forward. Next, look at V by I. V by I, and as this is the ratio of variables at different ports, we will use the word transfer. V by I is impedance. So Z21 is defined as open circuit forward transfer impedance. Next, Z22. This is I equal to 0, so we will write again open circuit, and ratio is 2 2. So the variables are both at port 2. So as port 2 is output port, we can write output. V by I is impedance. So open circuit output impedance. This is how we can define each and every parameter. Z11 is called open circuit input impedance. Z12 is called open circuit reverse transfer impedance. And Z21 is called open circuit forward transfer impedance. Z22 is called open circuit output impedance. The equivalent circuit of the two-port network is drawn like this. This circuit can be drawn from the equations itself. V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. So if you apply KVL here, we get the first equation. And here this is Z11 and this is Z12 I2. This is Z22. This is Z21 I1. This is the equivalent circuit for the two-port network governed by these two equations. Okay, this is all about Z parameters. And one more important point is, if Z12 equal to Z21, then the network is called as reciprocal network or bilateral network. Reciprocal network or bilateral network. This is all about Z parameters. That's all for this video. Thank you.